As a budding data engineer, efficiency is your superpower. Imagine spending hours on repetitive tasks that can be automated. Today, I'm going to add a new weapon to your arsenal, Python loops. So, let's jump in. But first, I'm Chris Gambill. This is Gambill Data Engineering, where we talk about all things data to help you become a master data engineer. And today, Python loops are going to take you a big step forward. Let's jump in. So let's start with the fundamentals. Python offers two primary loop types, for and while. For loops are perfect for iterating over sequences like lists, tuples, or strings. While loops are ideal for repeating actions until a condition is met. The basic format of a for loop will have the word for, a variable for the item that it's going to loop, the word in, and then the list. In this case, we have a list called fruits that we're passing into the for loop. So we're saying for fruit in this fruits list. And we're going to print the fruit. In this next example, we're looking at the while loop. So we're going to start with a count of 0, and we're going to say while count is less than 5. We're going to print the count, and then we're going to increment the count by 1. So the format of a while loop starts with the word while, the name of the variable that we're using, some type of comparison, whether it be equal, less than, greater than, whatever the case may be, what it's comparing to. So in this case, it's compared to 5. And then followed by a colon. You'll notice the for loop also had the colon as well. That lets Python know that what's coming next is part of the loop. In the fruit loop, we're going to print the fruit from the list, and that's the command that we're passing in. In the while loop, we're passing in count, and we're going to print whatever the current count is for that loop. And then to increment a numeric variable, all you have to do is type out the variable, and then a plus sign, an equal sign, and then the amount that you want to increment it by. It doesn't have to be 1. You could increment by 2, 5, 100, whatever you want to need to increment by. In this case, it's 1. So we're going to hit the play button, and we're going to see that it prints out what we ask it to. So at the beginning, we're printing out the for loop example. \n lets Python know that you want to go to a new line. So it's just a hard line break, the fruit list. And then it goes through and loops through the fruit list, and it prints out each of the fruits that we pass in via the fruits list. And then we're printing out while loop example, number list. Again, we start with a count of 0, so you'll see that it starts with a count of 0, and then counts 1 through 4, not including 5, because we did say less than 5. If we were to say less than or equal to 5, by typing in an equal sign and hit play again, you'll notice that it does print out the number 5. Let's take a quick break right here and share down in the comments a real-world application where you could use a for loop to automate a process. Let's dive into a real-world data engineering scenario. Imagine you have a data set with duplicate records. We can use a loop to efficiently remove the duplicates, add the unique rows to a data frame, and then push that data frame back into a table if you need to. But today we're just talking about the loop piece and how to remove duplicates. First, we're going to start by importing the Pandas library. The Pandas library is one of the libraries that we could use to create data frames. So first, we're going to create a data set. So we're passing in a JSON string where we're creating a ID field, a name field, and a price field, and we're creating 6 records within that data frame. We're creating a JSON string in this data variable, and then we're passing that JSON string into the Pandas data frame, and we're naming that variable df. That's a common nomenclature for a data frame. Next, we're using the def to define a function. So def just stands for define if you missed a previous explanation of Python. We're going to say remove duplicates. So we're calling this function remove duplicates, and we're letting this know that we're passing in a data frame. We're passing in a variable called df. In this case, it's going to be a data frame. We're going to create a new variable called unique rows. We're going to set df, the data frame, dot to records, where the index is false. So it's going to remove an index field that by default Pandas creates at the beginning of the data frame. And then we're going to say to list. So what that does is it creates a list of unique rows for that data frame. So again, this is a way specific to the Pandas library that we can remove the duplicates and then return a new data frame that doesn't have the duplicates in it, that just has the unique rows. So this next set, we're going to say, this is the remove duplicates piece, right? So we're saying df unique, so a unique data frame, right? We're going to call the remove duplicates function. dataframe.copy. So we're going to copy in the data frame that we created above and pass that into the function. We're going to say print original data with duplicates, and we're going to tell Python to print that original data frame. And then we're going to say data after removing duplicates, and we're going to pass in the unique data frame that gets created from the function. All right, so let's run that code and see what we get. So you see, we have the original list that has the duplicates in it. Apple, apple, banana, cherry, cherry, orange. So we see the duplicates with the prices. And then we have the data frame that gets created afterwards with only the unique records. Again, apple, cherry, banana, orange, without the duplicate records. So that's a quick and efficient way that you could remove duplicates from an existing data set. Keeping in mind that by using the PyODBC library, you can pass in a table from a database, create the data frame with that table, and then go through this same type of function where you're removing the duplicates from that table, outputting a new data frame, and then you could actually push that data frame back into your data warehouse by utilizing the PyODBC library. We're going to talk about a couple of different things in this next function. So we're created a new function called create new feature. We're passing in, again, the data frame. We're going to say for index, comma row in df.iterRows. So that's just iteration of the rows that are in that data frame. We're going to say price equals the row that we're on, and we're going to call the value for the price field in the row that we're on in that loop. Next, we're going to create a variable called discount. We're going to say the discount is 10% if the price is less than $2. Otherwise, it's going to be 5%. Next, we're going to say df.loc, which is a location within the data frame. And we're going to say index, comma discount, because we're going to put in what the discount amount is for that record into a field called discount. And we're going to say equals discount. Next, we're going to apply the discount and create a new price field. So we're going to say df.loc again for location, the index, comma new price. We're going to call the new field new price, and we're going to say equals round price minus discount times price, comma 2. And so what that does is it's going to keep the price within a 2-digit decimal place. It's going to take the original price and it's going to subtract the amount of the discount. And we get the amount of the discount by taking the percentage times the price. This is a normal pricing formula to calculate a new price based on discount. And then we're going to return the data frame. So this is an important piece of a function. Whatever you want to return is the keyword. And then in this case, we're going to return the data frame, so df. You could return any variable or any value. If I just said return 1, then it would return a numeric 1. In this case, we're returning the data frame, so it will return the whole data frame. So now, when we run this, we're going to run the whole thing again. And you'll see, again, at the beginning, we have our duplicate data frame. Next, we have our unique data frame. Then we have the original data again to show that that's what we're passing into the data with discount. And then we have another new data frame that incorporates the discount and the new price fields that we added in our function. While loops are versatile, they can be computationally large and expensive for large datasets. Consider using vectorized operations provided by libraries such as NumPy or Polars for performance improvements. However, understanding loops is essential for building custom logic and handling complex data transformations. In addition, the basic understanding of a loop will help you learn other programming languages as well. By mastering Python loops, you've taken a huge step in becoming a master data engineer. Be sure to practice regularly with different data sets and different use cases in order to continue to build your skills. If you missed our SQL tutorials, be sure to check those out here. If you've missed our previous Python tutorials, be sure to check those out. And if you want to continue your master data engineer training, be sure to like and subscribe for more information to come. Have a great day. You've had fun with data.